Let me start. So also my today's speech will be about data, with special focus in smart industry. So let me start with a quite trivial analogy between us as human beings and the digital world. So the analogy is to put together the eyes and data, because in a digital world, data are the way a company observes the world, the context where it is involved in. So this analogy could lead us to try to reason about data, considering the same, considering what we do when we normally interact with our world. And specifically, I would put the focus on three very important words that behind of them there are a lot of meaning. The words are looking, seeing, and understanding. And the first thing that I would like to share is that basically that looking is a physical activity, while seeing and understanding are two logical ones. What this means? Basically, when we look, we elaborate, we compute light stimuli. And so we must able, when we look a landscape or a beautiful place, we are able to distinguish the fine details, but also the overall view. And this is the same if we move to the data world. This means that when we cope with data, the first thing that we have to cope to is to able to collect the data, to access the data from a technical point of view. And as I said before, we need to access them wherever they are, whatever they are made of. So the look in a data terminology is the ability to reach, to measure, to reach, and to collect any data. Then there is one step more that we need to see. That is basically means that we need to be able to assign a meaning on what we look to on and in the data world on the data we have collected. Assign a meaning is not a simple task. It's easy to nominate, but it's a very complex one, because this is the level when there is a match between our brain, basically, and the data. So we need a tool, a solution that allowing us to clearly define this meaning. The third point is understanding. It's the most complicated, because it is when we, let me say, put together the data with the context where are involved in. So, for example, and this can be done at very different levels. So, for example, taking in a industry, in a manufacturing example, we can have a first level of connection that occur when we collect, for example, data coming from the sensor of a machinery. We collect all the data because we need to control the machine to stop the machine if something is going wrong. But then there is also a second level of connection, that is how to integrate the sensor data with other data that are internal to the company. For example, customer data, planning data, order management system, and so on, because very often we need to have a very broad view on how our machinery are performing. But then there is also a third level, when we can integrate the data with also external ones, like market trends, demand planning, economic situation, climate data, and so on. So there is a very different level to integrate data. Easy to understand that the value is growing as we move to the understanding phase, because is here, as I said before, that we realize the connection between our data and the world we are operating in. So this led to what I call the first key elements of a data virtualization, and it is logical physical separation. It is something that must be guaranteed, in our opinion, also on data. And the example is that of a library. When we go to a library, our first activity is to look in the catalog, not to take the books from the shelf and put all together on the desk or whatever. So there is the first activity is a logical one, because in this activity we cope with the meaning of the data. Then when we, let me say, decide which kind of books in the case of library, but data in the case of data, what data we need to reach our goal, then we can move exactly at that time to the physical level, because in the library example, we need to have really the books on our shelf or the data in our application or whatever. Now, to better introduce the data with virtualization, think for a moment of a library that doesn't own any books, but that has a so efficient logistic network that is able to take the book in a zero time, more or less, exactly in the moment when a specific book is requested. So a library that can interact so fast with the publisher to get the book on demand. In this case, imagine the advantage. A library has not to purchase any space because they don't need to store anything. A library will have always the latest edition, because he simply requests to the publisher the books that is needed by someone. And also has an optimal management, because in this case, there is no risk to buy those books in advance that will never be requested by someone. So there is a lot of optimization, and this is basically the key element of data virtualization, not only to split the logical and physical phase, but also to avoid to copy or replicate the data just to integrate them. We move the data just when the data are requested by someone. Second point, data catalog. This is one key point. Also in the previous speech, and also when we were in the private room, some people say that it's not easy to understand which data are available in a specific company. In reality, it is when the data catalog comes in. But a data catalog itself is not enough. We need an active data catalog, exactly as the catalog of a library. We need a descriptive data catalog to understand the meaning of the available data, but then a data catalog must keep the link with the real data, with the place of where the data are stored, because only in this way there is, let me say, a very fluid process to use and consume the data. Imagine a library that in its catalog doesn't report the shelves and the position in the shelf where the books are. It will be completely out of any value, because you can find the data you need to, but you don't have any indication how to get the data. So active catalog is what we call the key element number 2 of data virtualization solution. Last but not least, one place to know, many to use, just to say that a data catalog must be logically unique. That means that there should be just one place for anybody to look for the data. This is the best way to, let me say, to realize the data democracy. So giving to everyone the possibility to have just one place to inspect, to know which kind of data are available, and to let anybody to understand if the data they found are good for its specific goals, or if it is not the case, give them the possibility to combine also the data. So to create a sort of new data, putting together different content, exactly like, again, in the library example, when we take different books because we need to extract some meaning, some content from different books, put them together to realize our research or whatever. So this is exactly the same to data. And this is what we call, key element number 3 of data virtualization. So logical physical separation, active data catalog, a unique point, a unique place to understand the data. This led us to the essence of data virtualization that basically can be realized with a new level, that is a separation level between the data and the data consumers, that offers specific capabilities that are those that make the data virtualization possible. So access any type of data, abstracting the complexity. This means that in data virtualization for the node, for the Denodo solution, when we collect or integrate with data, we represent the meaning of the data with a unique format, that is the relational one. So any data, independently of how it is represented in the data source, is presented like a set of table and connection. That is basically the relational model. As I said before, we don't need to replicate or copy the data, so we are able not only to make all the data available to any data consumer with different protocol, but also to make the data available on demand in the real time or right time, because the move between logical and physical part is put in place in the exact moment, in the very moment when a specific data is required. So we don't need replication on data. And last but not least, we offer a set of functionalities that make the data virtualization practically to make data virtualization to be effective in a real context, because data virtualization is not something that is that live on themselves, but that must be integrated in a very complex information technology context that is the one of any company. So I mean, I'm talking about governance, security, and whatever. Try to make one step forward. We can use also a data virtualization approach for what is normally called enterprise data fabric. You know, data fabric is probably the most modern concept about data integration, and it is strongly based on let me say, a super connection between different data, independently of the data location, of the data structure, being them structure or no structure or whatever. So the idea is to create a sort of hyper connection between data, and again, to make available any data to any user. So the overall enterprise data fabric architecture is quite obvious, to have data and users at the bottom and at the top of the design. In the middle, have the enterprise data fabric architecture, that in the case of data virtualization is based on the main concept of the 3 key elements that I described before. So universal access, data abstraction, logical view, plus security, and plus, last but not least, the data catalog. I use the term self-service because data catalog is something that must be consumed also by non-technical users, like normally data consumers are. I left a special place for data silos because, you know, it's something that we are always discussing about. In the data virtualization approach, data silos, let me say, must be there, must not be destroyed, because this is the wrong choice that we can make, because a silos is something that has been built to protect its content, not to prevent the content to be available to others. So in a data virtualization approach, exactly because we don't require any copy, so we don't require to take out the data from a data silos just to let them available to others. In our approach, each silos could have a mini, let me say, data virtualization layer on top of it, that is the, let me say, act as a communication, a bridge between the silos and the users that want to use the data that are collected in, without bringing out the data from the data silos, with the obviously exception when the data is actually used. But also in this case, the data virtualization is just a delivery manager, because he takes the data from the data silos, transmit the data to the users, but that doesn't copy the data in any place. And this is the overall architecture of enterprise data fabric, that is basically the modern way to make any data available to any users. I go into the conclusion just to report a use case, an interesting use case. Schaeffler, sorry for if I pronounce in the wrong way, is a company that made bearings for automotive, but also for industry. So it's a clear, a typical manufacturing company, a big one, a multinational one. And his business needs, as you can see, is basically that to make data available. The problem was the data is distributed in different silos, different organization department, so it's not easy to make them available. And very often the needs to have data will result in the past, before the data virtualization approach, in a point-to-point integration that is, from an information technology point of view, is probably not the best solution that we can put in place. So the solution is to introduce a new data platform based on data virtualization context, allowing them to easily integrate and consume data, but also to reduce cost, because with data virtualization, they basically reduce time needed to make any new data available to others. So they moved from a very old style solution that is the classical spaghetti architecture, that is essentially a point-to-point integration. So when there was a new use case, the solution was, okay, which data source must be interested by the use case, select those data source and make a point-to-point integration that results in the architecture you are now watching on the slide. And this is very difficult to maintain, probably very low performance and so on. So the idea is to move to a more modern architecture to keep for sure the data sources, but realize a new data platform that is able to, this is very important point, so to keep the physical data hub. So this means to keep the data physically where they are, but to also to virtualize them, to make them available without the need to move the data in a new physical location, for example, I don't know, a data warehouse or whatever, and then make them available. So the idea is to preserve the data where they are. Remember the data silos example, but build a virtual layer on top of them that implements the three key elements I described before, and to allow any users, any use cases, anyone that has to consume the data to interact just with this data platform. So to have the unique access point to data, where the meaning of the data can be explored, can be shared, where new data can be modeled to answer to specific requests, or putting together different data to create a new data asset, and all of them accessed through a data catalog, and to support any business users, any request. So again, and this is my last slide, the solution is to rationalize the data platform, because we need to consume data as fast as is possible. Thanks. Thanks, Musin. This is my just slide, so it's my, let me say, takeaways.
Thanks a lot. Shall we start with questions?
Yeah.
Okay, Andrea, if you click the
chat, yes,
chat box as well, so you can see the first question from Paolo.
Yeah.
which are the main parameters to be considered to define the timing for implementing from the scratch the data visualization? What is the average time to be spent on data visualization?
Let me say that very good point, because you know the data virtualization, any activity must be practically. So normally what guide a data virtualization approach is an incremental project, so it's not absolutely a big bang solution, is to be driven by a use case. So normally we select, or the customer select the most urgent use case to work on, and the use case will select as a consequently the data source to be started on. So we normally start with a few data sources, and let me say gradually implement a data virtualization platform. In a data virtualization platform project, sorry, the most of the effort is in the modeling part. So this means that we connect the data source, represent them in the logical layer, and then in that layer combine the data, create new data and whatever, and then make the data available to the consumer. But finally, it's absolutely an incremental approach to data virtualization.
Thanks a lot. So I hope, guys, you are not running away still. We have still questions for Andrea, and then at 2:20, everybody to get back here for the rest of the presentations, because we have now lunchtime. You go anywhere you wish, but 2:20 coming back online again. 1 year we are working on this project. I hope everybody will be back. I skipped the first question from Safran Group, from Francis. Could you explain difference between ETL and VM approach?
Yes, ETL is based, to describe ETL, you have to think about a data warehouse. This is the typical ETL approach. So data warehouse becomes quite often before the data lake, because now there is a sort of fight between the two. Data warehouse was a single point of access to many data of a company, but it was based on a TL approach. That means that the data were copied out of the original system, typically a transactional one. They were organized and put in the data warehouse. Data virtualization does not imply to move the data to a new physical location just to make them available. So just to give you an example, in probably 80% of our project, one of the key data source is the data warehouse or the data lake, plus other data sources, some operational application or whatever. Data virtualization means that we don't need to copy again the data from the data warehouse and the other system to create a new, let me say, big data warehouse or whatever you prefer to call, just to let the data available to the data consumer. We are able to take the data from the data warehouse and other data sources, depending on the data that are used, on demand. For sure, there is also another question about the real time and the performance. I assume that we don't have enough time to respond, but if you drop me an email or whatever, I can for sure respond to any question to anybody. Absolutely.
Perfect. So you can see there, Paolo Bartolazzi from Maire has the question. Then on the LinkedIn group, you can reply here.
Yeah,
Paolo,
I just saved, let me say the name, so to be sure to answer to
yes,
anybody.
Paolo.
Okay, thank you guys. Thank you, Mohsin.
So then I have last question from Abhishek from Switzerland. He's with us with this question. When you do real-time query, and if the query is getting data from multiple sources, the performance can be affected based on number of users, etc. What kind of architecture Denodo uses to do this?
Yes, again, a good question. Yes, the performance can be affected by different factors. The Denodo support hybrid architecture. So, for example, you can have a Denodo instance close to any data location. So suppose you have some data on premises and other data on a different cloud provider, you ideally can put a physical Denodo instances on any location and then control all the instance like a unique logical data integration view. Denodo has a very super performant query engine that is